Consider the sequence 8, 4, 2, 1, a half, and so on and so on. Part A, show that the sequence is geometric. Part B, find the general term. And part C, hence, find the 12th term as a fraction. So show that it's geometric. Now, a geometric sequence is defined as something with a constant common ratio, e.g. the number you times a term by to get to the next term is always constant. So the way you show this is to take a term and divide it by the term previous. So if I say, well, 4 divided by 8 equals a half. If I do it, that's A1 and A2. So if I did it the same with A3 and A2, so 2 divided by 4 also equals a half. Then I have 1 divided by 2 equals a half. So that was A2 over A1. This was A3 over A2, and this was A4 over A3, and it should keep working and working and working. So even if I had a half divided by 1, it's still a half, right? So, constant common ratio. So sequence is geometric. Right, part B, find the general term. Well, general term an equals a1 times r to the power n minus 1, right? So a1 is the first term, is 8, r equals a half, so general term an equals 8 times a half to the power n minus 1. Done. Part C, we're just going to use our result in part B, so find the 12th term as a fraction. So we need a12, we literally substitute for n equals 8 times a half to the power of 12 minus 1, so equals 8 times a half to the power 11. So that we're going to have to do a bit of work with powers of 2, so hopefully you know that 8 is 2 cubed, and hopefully you know that a half is times 2 to the minus 1. So this is, the 2 cubed is 8, the 2 to the minus 1 is a half, so then we can sort of simplify this equals 2 cubed times, well, powers on powers times 2 to the minus 11. So you should know here we need to add the indices, so 3 minus 11 is minus 8 equals 2 to the power minus 8, which is the same as 1 over 2 to the power 8. 2 to the power 8 is, well, 2, 4, 8, 32, 64, 128, 256, 512. So it's 1 over 512.